Dari, hello. It is March the 22nd, 2022, and this is a video clarification about Cromemco software compatibility. Now, in a previous video, I may have given the impression that Cromemco Unix systems could run other than 32-bit Unix programs, and I'm afraid that is not what I meant to say. What I meant to say was that they're on their latest and greatest product, which was using a Motorola 68020 CPU, which had the capability to run Unix. On that operating system, it could only run Unix programs, but that the same hardware, if booted with Cromemco's own Cromemco operating system, and in particular the version 172 XXU, as I would call it, that could run a whole variety of other software for other platforms. And so what I've tried to do is to produce a little table. Of course, I've actually done the work to check all of this out in detail, and apart from one column, it's looking pretty complete. So on screen you have the results of the analysis. So across the top we have the different operating systems in question. So we've got Digital Research's CP/M, Cromemco's CDOS, Chromix 11.27, which is the last Z80 version, Zilog Z80 version, Chromix 168, which is the last 68010 version that I have, Chromix 172 XXU, which is the version of Chromix specifically for 32-bit processors, and I'll clarify what I mean by that in a second. Then we've got Unix version 5, which ran on 68010 processors, but you had to have a memory management unit connected. And last but not least, the system that's running right now behind the screen, which is the software is Unix 5.2, and it's running on a Motorola 68020 with a memory management. And down on the this axis here, we've got all the programs I've tried. So we've got CP/M's WordStar, we've got Microsoft MBasic for Z80, we've got Cromemco's Assembler, we've got Cromemco's 32K Structured Basic, fantastic product. We've got their Z80 based screen editor. We've got the CE screen editor for 68,000 platforms. We've got the CE editor version 179 for XXU platforms. We've got the Chromix commands ls and crc. And finally, we've got for 68020 Unix, we've got the ls command and the CE editor command, and we've also got the CE binary for the 68010, so that's this guy's Unix as well. So the reason why this column is blank is that although theoretically speaking I've got the CPU card, the 68010 CPU card, I'd need to connect that to a memory management unit, and I just haven't got the will or wherefore or the cables or the whole mindset would mean taking the whole computer apart just to produce this column, and I just don't want to do it. So that column is pretty blank, but we can make educated guesses as to what it would be, and that would probably be crosses in every area. But let's go back to the CPUs in the first place, because I'd like to point out that there are 3 CPUs in question, and we'll just go through the different processors. So we've got the, we can get the right visual here. So this is the Wikipedia page for the Zilog Z80, which was the processor used in their first systems. As you can see, it's got a data width of 8 bits and address width of 16 bits, so it could address 64K worth of memory, and the data bus was only 8 bits wide. The next product was the Motorola 68010, so that's the 68010 product, and that's got a data bus of 16 bits and address bus of 24 bits. So this could have up to 16 megabytes of memory, quite an increase. And that was the processor used in the DPU and XPU processors from Cromemco. And don't forget, on the DPU and XPU they had a Zilog Z80 as well. So it was a fantastic card because it had two different processors with different programs, different processors allowing you to run more software, as we'll verify in a second. And last but not least, we've got the 68020 processor, which was sort of given to be a 32-bit processor. And why? And that's because both the data and the address bus were set to 32 bits. So that's the processor in the last Cromemco card, which is the one that's running on this behind the screens here, which is a 32-bit processor with a 32-bit data bus and a 32-bit address bus. So that's the processors, and that's the results, if you like. But I wanted to show you the actual results and how that was achieved in some small part. So if we open the kimono, we've got here running the Cromemco Unix system running on the 68020 processor. And in that directory, the TT directory, so in PWD, TT, ls-l, we'll see I've managed to put these files from all these other different architectures. Now, the time to make this test was just bounded by the fact getting the software on here was totally and absolutely non-trivial. And I'm just signposting it for people who are in this position. So I've got a virtual machine running here which shows you how I managed to affect that transition. So this is a virtual machine running Windows version 10. There's no reason why I couldn't have used Windows version 11. But just to say that this is a licensed machine whereby I'm running Windows version 10, and I first of all put into the file system all the programs I want to transfer. So here are all the programs, and then I run Damien's fantastic program, Damien Wilde's fantastic Java-based program, which allows you to take an arbitrary set of files and via these command flags allows you to create a David Dunfield IMD file. So IMD is this industry standard way of exactly capturing the information on a floppy diskette in terms of density, rotational speed, intersector gaps, and of course the data itself. So this amazing program, and it's a real step forward, I would say, for the vintage community, allows you to create without the actual hardware an IMD file, and this is absolutely revolutionary. So thank you very much, Damien. It's really been a leap forward. So using his program, I could create an IMD file. Then, using the HXC floppy emulator program. So the HXC floppy emulator is, as it sounds like, a digital emulator. So it can read an IMD file and output that file in its format, which is an HFE format. So I can load, never do a demonstration without testing it first. Anyway, let's just do it anyway. I'm doing it. Load the IMD file. So I'm loading that up there. And it's loaded it. So it's a 77 track 2-side file. And then I can say save as image. So I can then save that as an HFE format file. So let's just call it Fred. There's one already, but there's about to be a rewritten Fred. Let's replace it, yeah. So if we go into here now and go into the directory and look for Fred. So you see that's right up to the minute. It's written to that directory, the HFE file. So then I can carry that file, put it onto the SD card, plug it into the Cromemco system, which has got the HXC emulator, boot the system, but unfortunately, of course, Cromemco Unix can't read that file. So I've got to first of all boot into Chromix 172XXU, load the files into Chromix, then get another virtual diskette, load that diskette, format that diskette, and then tar. So this is a process of trial and error. I found out I couldn't write in uniform format. I had to tar the files using the tar command onto this another HFE file, which is a virtual file. Then finally reboot the system. So I'll take this away now. So reboot the system, and then there is a file plugged in and working on this Unix system which contains in tar format these files. So if I was to do a tar minus have a look verbose file or /dev/fda and then shut up, you'll be able to hear the beeping. Is it seeking? Can you hear that? Click. Look at the screen here. It's had a look. It's found the second file. Okay, so let's see if I can break out of that. Okay, I can. That's great. So we're in this directory, ls-l, and for example, let's try and run a Unix ls command, which is 19k long. So /that -l, and unsurprisingly that works. And if you do a version of that binary, you'll find that it knows it's a Unisoft version 1.0 binary, and it's old A.out format, system 5. So actually, that's interesting. That is the 68,010 binary. Okay, because that's the 68,020 binary. Just looking at that, look at the difference. Yep, so that's the binary for the true native system. So interestingly, the Cromemco system can run programs written for the older version of the processor, the 68010 processor, and it can also run its native binaries in COF format. That's interesting. Did I reflect that on my compatibility too? I did, because here I was trying to show you that version 2 of Unix can run this 68010 program here. So I did notice that. But can it run anything else? So let's take, it's a real long shot, let's take structured basic, which is sbasic.com, and try and run it. So I'll say /this. And as you can see, it does try and actually run it, believe it or not, but it doesn't get very far. So luckily it doesn't crash the system, but it's just garbage. So we cannot run Z80 programs here. Can I run a binary that was written for the Chromemco operating system? So let's look at the CE editor. It's a bit unfortunate running these programs because of course they could jigger up the emulation screen that I'm looking at. Anyway, let's give it a go. So /, okay. You see, it just will not run it. It tries to run it. In fact, in my mind, it shouldn't actually run it, but it does make an attempt to run it, which in a way is bad, because it could destabilize the system, let's say. So it does try and run it, but just doesn't get anywhere. So I can't run binaries written for the XXU Chromemco system. I had, what did I have here? I had 174 of the CE editor. I don't have that listed here. Here's a CE editor. If I do version on this program here, it doesn't even think it's a binary. It just is, you know, it's yeah, it can't run it. It can't run it. So what I'm trying to show you here is that the system, the Unix Cromemco system, can only really run programs written for Unix, and as such, it's grossly inflexible in terms of what you can actually do with it. to actually do anything other than compile your own software and run it. Comparatively speaking, the same hardware, if running Cromemco's own operating system, can run everything except the Unix programs down here. If you try and run it, you get an out of memory message here. It doesn't crash the operating system, but you don't get anywhere. But the most flexible in a way system is the Cromemco 172 XXU based system running Chromix 172 XXU, because you can run everything. So it can run Z80 programs, it can run CDOS programs, it can run Chromix 11.27 programs, it can also run Chromix 68K programs, and it can also run its native 68020 programs. So the most compatible, most all singing, all dancing Cromemco system, I would say, is the latest hardware running the Cromemco Chromix operating system. And I'd just like to show you some of the underpinnings as to how that's possible. So stick with me. We're going to look at the manual for Unix. So let's look at the Unix manual. So this is what you'd need to better configure the system. You can get both pages on there. You can. So if we go into the manual and we look at the ways to configure the system, you'll see that there's various chapters, and there's something called Configuring the Unix Kernel, Chapter 10. So we're going to look at the configuration options for the Unix operating system, the 32-bit Unix operating system on Cromemco system running 5.2 Unix. So we need to find Chapter 10. Where are we? Chapter 10. Come on. The appendix. We need Chapter 10. Appendix. We're getting close. 12. Come on. Here we are, Chapter 10. So you can see that we can change a lot. Let's go to the top here. So this is the file that allows you to change the kernel. And what can you change in this kernel? Well, you can change typically things like buffers. So here are all the things that you can change. So you can change kernel parameters like this. Default file size limit, interrupt vector for parity errors, buffers of various different sorts, inodes in the inode table that are stored within the kernel, etc., etc. But nowhere can you change anything to do with the hardware. Well, sorry, there's a few exceptions. You can change the number of ESDC or STDX cards. So you can change these disk devices here. And you can actually also change the Octite driver, which is the 8-port serial card. You can change that there. But you can't add or subtract other types of driver. Let's look instead at the Chromix sysdef file. So when you configure the Chromix operating system, you have a file called sysdef. You can call it anything. And here are the caret devices that you can select. And here are the block devices that you can select. So this would be the uniform floppy here, block device 2. This is the hard drive, the STDC driver. This would be an SMD type of disk. This would be an ESDI hard drive, and drum roll, this would be the I/O processor, the ZIO. The ZIO is the Z80 based I/O processor. So let's just see if we can find something about the ZIO. Again, yeah, this is possibly going to be proved, but have they got a help section on ZIO? Oh, good, we have, yeah, uniform floppy, a floppy tape, the RAM disk, the STDC hard disk controller, and here we go. The ZIOs, so you can put in, like, you can put, for example, ZIO space 1, ZIO space 2, supports Z80 based programs running on the BIART, Octart or IOPX, one per board. Ensure that the boards will have the code downloaded, see IO startup.cmd. Okay, arguments are the number processor numbers. So in other words, for the Cromemco operating system running on the 68020 even, or the 68010, we can edit this file and relink the operating system, and we can tell it that we've got an IO processor, and that is how you can run Z80 programs on a Cromemco 172 XXU based 32-bit operating system. Can still run the 8-bit programs from the Z80. It can also run the effectively 16-bit 68010 programs from the slightly junior version processor. And that is probably the longest explanation in history, but that's what this chart is showing you, that this column here with the Z for can run but needs ZIO shows you that this platform can run just about everything. So I'm afraid, Mr. Unix system, it's time for a shutdown, and at least it will be. It's time for a big shutdown, and I should be rebooting and using Cromemco on the system, and not ever really touching Unix again on this platform. Okay, Darry, thank you for watching.